Alright, welcome back SPH4U to light and reflection. So when we talk about reflection, we're talking about the occasion in which light bounces off an object. And of course we know that the type of material will definitely affect the reflectivity of the light, and in some cases don't reflect light at all. Certain materials are not good reflectors. But here we're going to work with varying levels of reflection. There are three laws of reflection. The first is that an angle between the incident ray and the normal is equal to the angle between the reflected ray and the normal. The second is that the incident ray, the normal, and the reflected ray are all in the same plane. And the third, of course, has to do a little bit with reflection and refraction. And it states that the incident ray and refracted ray are on different sides of the normal. So let's say we have a high reflective surface like the mirror. The first law states that the angle between the incident ray and the normal is equal to the angle between the reflected ray and the normal. And we have a source of light. Let's say this source could be a flashlight of some sort. So we'll just write flashlight. Okay. And it is shone to the surface like this, and it hits the surface, and then we all know that if you shoot a laser or a light at the mirror, it bounces right off. So the line in blue here would represent the incident ray, which is really the light that comes from the source. And then we have the reflected ray, which again bounces off here in red. Now the line that separates the two is called the normal line. So whenever we speak about the normal line in physics, it's the line that separates the incident ray from the reflected ray. So this is our normal line. And there's a couple of angles to look at here. When we're talking about the angles of the incident ray and the reflected ray with reference to the normal line, so we go theta I, this law states that the incident ray angle and the reflected ray angle with respect to the normal line is going to be the same. And so the box in purple over here is really the summary of your first law of reflection. And so the green here would be your incident ray with regards to the surface, not the normal line, and the angle in orange would be the reflected angle with reference to the surface. But when it comes to the first law of reflection, we're only interested in the reference to the normal line. For the second law, when it says that the incident ray, the normal, and the reflected ray are all on the same plane, if you think about the blue box here as the plane, this of course would be your mirror, so this is what's doing all the reflecting, and I have my source of which my incident ray comes from over here. Your reflected ray would bounce off again on the same plane, and your normal line would all as well in purple here be on the blue plane. So your incident ray, your reflected ray here in green, and your normal line would all be on this blue plane over here. So our first example reads, an incident ray strikes a mirror at an angle of 35 degrees from the normal. What is the angle of reflection? So if we draw this scenario out here, here is your mirror, okay, and your incident ray, which comes from the source, is going to strike 35 degrees from the normal. The normal line is going to be in the middle here, and the angle between the angle of incidence and the normal, as we said, is 35 degrees. So what is going to be the angle of reflection? Well, the first law of reflection states that the angle of incidence is equal to the angle of reflection. So if the angle of incidence is 35 degrees, then that is the angle of reflection. Our second example reads that a light ray strikes the mirror 25 degrees from the surface. What is the angle of reflection? So once again, if we draw this here as the mirror, the light ray is coming in like this. Let me try and draw that a little bit straighter. Okay. And of course, it's going to reflect off, since the mirror is a highly reflective surface. We have the normal line, which is going to separate the incident ray, okay, and the reflected ray. Okay, now here's what the question actually gives us. It says it's from the surface, which means that the 25-degree angle is actually here. It's not the incident ray angle. And so what we have to do, using a little bit of geometry, we have to figure out what this is in order to derive this. So since this forms a 90-degree angle here between the normal line and the mirror or the surface, then we're going to go for your incident ray. It's going to equal to 90 degrees minus 25. And when we do that, we end up getting about 65 degrees. And as the first law tells us, that the angle of incidence is equal to your angle of reflection. And so that too would be 65 degrees.